Hi folks, we're going to take a look at question 7 from page 110, and in this question here they're asking us to find the x, y, and z intercepts of this line here. Okay, so the question is, what does it mean to be an x-intercept, a y-intercept, a z-intercept? If you can't think of it right off the bat, why don't you draw yourself a little picture here? Okay, x, y, z. And if you live on the x-axis, meaning if you're an x-intercept, you realize that your y and z components have to be equal to 0. Okay. Similar, if you're a y-intercept, it means your z and x components have to be equal to 0. And if you're a z-intercept, your x and y components have to be equal to 0. Now, one thing to keep in mind is because this is a line, there's no way that a line can have all 3 intercepts. Okay? It could conceivably have 2. Okay? It could have only 1. Or, of course, it could have none at all. It might just exist away from the 3 axes and not cross any of them. So again, that's different from 2D, where a line, unless it's horizontal or vertical, has to have both an x and y intercept. Okay, so let's go with that idea here. So if I'm looking for an x-intercept, okay, I need y equals 0 and z equals 0. That's the important thing here, is that they both have to be equal to 0. Okay, so let's set y equals 0. Okay, that means I have to find a t value that's going to make 4 plus t equals 0, and that t value is going to be negative 4. Now that same t value is also going to have to make z equal to 0. Okay, because remember, we're looking for a point on this line that's also on the x-axis. So it has to both satisfy that y and z are 0, and it has to satisfy this equation here. So let's take z. Okay, let's take the z what am I trying to say here? The z equation, okay, and see if that is going to give us 0. So if I take negative 20 minus 5 times negative 4, okay, what does that give me? Well, negative 20 plus 20 is equal to 0. Okay, so that means that the same t value will also make z equal to 0, meaning there is an x-intercept. How do I actually find that x-intercept? Well, now I can just stick it into my equation for component x. So 24 minus 7 times, plus 7 times negative 4. So 24 minus 28 equals negative 4. Okay, so the x-intercept of this line is equal to negative 4. Okay, now let's see what happens with y or z intercept. So if I'm looking for a y-intercept, okay, here I need the x component to be 0 and the z component to be equal to 0. Okay, so let's see what makes our x component equal to 0. So we have 0 equals 24 plus 7t, and so negative 24 equals 7t, and t has to be equal to negative 24 over 7. Okay, but is this t value also going to make z equal to 0? Well, I could check it, but I actually checked that already because I know what's going to make the t value equal to 0, negative 4. But if you're not convinced, let's just check it out here. 0 equals negative 20 minus 5t. So negative 5t is equal to 20. So t has to be equal to negative 4. Okay? Meaning there's no t value that makes both the x and z components equal to 0. So that means we have no y-intercept. Okay? And then again, if we think about the z-intercept here, we need x equals 0 and y equals 0. Okay, but let's take a look. What is it that made x equals 0? We needed a t value of negative 24 over 7. And what was it that made y equals 0? We found out earlier we needed t equal to negative 4. Okay, which means it's not the same t value that can make both x and y equal to 0. So here it means we have no z-intercept. Okay? So the line does pass through one of the axes, but it only passes through the x-axis at -4. Okay? And that is it.